Okay, good afternoon. Hope everyone had a good lunch and is not tired for this. I'm Scott, and I'm going to go over lessons learned building a highly available serverless client portal on AWS. So, what do encrypted one-time password codes, base64 encoding, and Azure Active Directory have in common? Well, they all tried to break my company's serverless client portal. None of them ultimately succeeded, thankfully, but each taught me something AWS documentation did not actually mention. So about me. I'm the cloud professor per ChatGPT from what I gave it about me. I work as a cloud engineer at a small weather forecasting company in the Chicagoland region. I'm an AWS community builder. I'm working on a Doctor of Technology through Purdue University Online. It's not Purdue Global, it's actually through the West Lafayette campus, just to make that distinction. I love to travel and storm chase, and that is a picture of a tornado I got on one of my storm chase trips. And I've been into painting recently, and video gaming. So, the legacy architecture challenges we had was we had EC2 instances, which require us to manage them, all that fun stuff, and over provision, right size issues, and as a weather company, weather events cause sudden traffic spikes that we can't predict. And since we're a small weather company, cost is a factor, so we always only had one EC2 instance running. We had an over-provisioned RDS database. Because again, we wanted to make sure we had enough, but we didn't want to go too high. It's all that fun stuff. And also single AZ, no high availability. And expensive for a limited usage pattern, but again, we wanted to play it safe. Our website used WordPress, which adds complexity and bloat. I'm not a fan of WordPress at all. And one of the plugins we use for our client portal is no longer supported. So that caused us to have to look at other solutions. So I came up with a serverless architecture solution, which helps with the weather patterns, the different traffic usage based on that, users coming in to collect snowfall reports after an event, so utilization just varies. So we use Amazon Cognito for authentication and authorization. It handles the registration. We don't allow self-registration. The admins do that. But then login and JWT token management. It's also an internal portal for us as well. So it integrates with Azure AD via SAML. And then for our clients, it just uses Cognito users. And this just makes it where I don't have to manage the user credentials, store it in a database, all that stuff. Cognito just does it, and there's built-in security features such as the one-time password login. Then instead of using EC2 to host the website, we use Amazon S3 and CloudFront for the static website hosting and to host our client files. So it's just a Vue.js single-page application. CloudFront provides the global CDN with the edge caching. This is mainly just used to keep the S3 bucket private and caching the static data. And this provides automatic scaling for traffic spikes. And no server management. Yay! We're using Amazon DynamoDB to store just a little bit of client information that we need that can change, so we couldn't really store it in Cognito since you can't change what you store in Cognito after you create it, so using DynamoDB for that. So this stores users' preferences, file metadata, and portal configuration, just lightweight stuff. And we have global tables for multi-region availability. And we do pay as we go instead of using provisioned capacity. Then we use API Gateway in AWS Lambda for the actual API that is on the static website for the dynamic content. So it handles the routing, throttling, cores, and authorizers. Lambda provides the compute and the automatic scaling again. Just nice, easy, serverless, less work for me as a solo developer on my team. And then, of course, the CloudFront CDN, just a unified endpoint for everything. So the architecture diagram, just to visualize all of it, got the user with the CloudFront pointing to S3 bucket, Azure, Cognito, single sign-on for corporate users, the Cognito users for clients, API Gateway, Lambda, that ties into S3, DynamoDB, and then, of course, CloudWatch. So yeah, no servers to manage, everything scales automatically, and built-in high availability through managed services. So, the first challenge we came across was within Identity Federation. So the problem was, we have groups within our EntraID, and those weren't flowing into Cognito. Everything I read said that they should be flowing into Cognito, but they weren't. We could log in, but the groups just weren't there. So the role-based permissions was not syncing over. So I was using OpenTofu to manage the infrastructure as code. So tried to configure a SAML attribute mapping through that. It didn't work. Tried to go into the Azure portal, go into settings, emit groups as role claims. Didn't work. Kept trying. So eventually, with the help of AI, because I was getting frustrated, it came up with, and I tested and it worked, a pre-token Lambda with using Microsoft Graph API. So the pre-token generation Lambda trigger is a function that runs during every authentication. Lambda then queries the Microsoft Graph API directly using service principal credentials, which is stored as a secret and parameter store. It retrieves a user's group memberships programmed through the code in real time. And it adds filter groups such as portal admin, OFD admin, OFD user, our forecasting division, as a custom Entra groups in the JWT tokens. And then it uses something called claims override details to inject custom claims into the token. So the key takeaways: sometimes standard integration path just doesn't work. Don't spend too much time fighting with configuration. Consider API-based alternatives. Lambda triggers provide powerful customization when built-in features fail. Real-time API calls can be more reliable than claim-based approaches. And have a failback plan. The next challenge was dealing with AWS encryption complexity. And this was in involving our custom email sending. So when the default Cognito method of sending the one-time password to log in was so generic. It was just like, hey, here's your code. It didn't tell you what application it was from or anything. It's like, okay, who's this from? So we wanted a custom HTML email with our company styling for the login code so people knew it was from us. I, for the life of me, at the time, could not find any documentation for decrypting one-time password codes in the custom email center. No clear examples, and I had to piece together information from multiple sources, and again, use AI to help, which I probably spent a couple weeks on this one problem. At the time, it was Amazon Q, CLI. So it even couldn't figure it out. So we eventually figured out we needed to use a Lambda function with AWS Encryption SDK version 4 with a material providers library for the one-time password codes. But we had to do that as a custom Lambda layer instead of using the one Amazon provides, because the one Amazon provides does not have the NPL library. So the reality of this problem was there was way more time spent researching than actual coding. Kind of had to reverse engineer. Couldn't find no clear documentation. This is how you do it. Success came from persistence, not clear guidance. And the key takeaways from this was documentation gaps exist. Make sure you budget time for research. And be prepared to experiment when documentation is unclear. And of course, document for future developers. And this is just code showing all the different Python libraries I had to import. Had to use base64 decoding, set up the SDK client, set up a KMS client, create the material providers library, do a KMS keyring, then finally be able to decrypt. So, not the most straightforward, oh, this is how to do it. I just thought I could just use KMS by default, because KMS was the encryption option. So that's what I thought. Now, cores. I do not like dealing with cores. So, had cores issues when calling the API gateway URL directly from the front end. That was because of the different domains between the static site and the API gateway URL, causing the browser blocks. And core's pre-flight requests were failing or being inconsistent. So tried to configure core settings in the API gateway, added proper headers and allowed origins, was still experiencing intermittent failures. There was complex debugging of pre-flight option requests. And after dealing with the one-time password decryption for a few weeks, I did not want to spend a lot of time on this. I was like, no. So I wanted a quick and easy solution. So, at the time, I found CloudFront origin groups with a URL rewrite function. So I created a URL path of /API/* that routes the API gateway within the CloudFront. There's a CloudFront function that rewrote all the URLs to API gateway. The function strips the /API prefix and forwards it to the actual API gateway endpoint. It was working. No more CORS issues, everything in same origin. But we will come back to this because this is not the end of that story. Then the next issue is we wanted multi-region. And so I thought the IAM permissions would be easy. They were not. So the goal was the single endpoint for multi-region S3 document access. So I set up a multi-region access point, but was getting access denied errors despite having the MRAP ARN permissions in the policy. I'm like, okay, why? You also had to give the policy permissions to the actual bucket, not just the MRAP. I'm like, okay, I guess that makes sense. Turns out Bodle 3 in Python, might be other SDKs as well, internally resolves the MRAP ARN to the underlying bucket names, hence why you need their bucket names and those permissions as well. So you have both the MRAP ARN and buckets in both or all regions in the policy document. No big deal, just something I found out in the process. So then I was trying to use pre-signed S3 URLs to deliver the documents to our clients. Figure is a simple, clean approach to redirect our users to temporary S3 URLs. I thought it was going to be straightforward. But if anything has taught me through this process, and as you have seen, it was not. The pre-signed URLs would not properly display or download in the browser. The downloads would be binary files, not the actual file type of like PDF. Like, why? So I, again, spent significant time on this problem. I attempted various S3 configurations and headers, tried different approaches to content disposition headers. I just couldn't get it to work. And again, solo dev, I have to get this whole project done. I needed to find a solution sooner rather than later. So the fallback was to use a Lambda proxy with a base 64 encoding. It's complex, but it works. Like, okay, I can get this shipped. And for my company, sometimes that's good enough. So the Lambda function fetches the document from S3 through the API gateway, use base 64 encode to the binary content, so API gateway can understand it, and then frontend decodes the base 64 and creates blob URLs for browser display. And then that way I have complete control over the headers and content delivery. So sometimes the simple solution doesn't work in practice, or maybe taking too long to debug research, so you have to move on to another method. Don't spend too much time fighting with things that are not working for you, and sometimes complex solutions are the way to go if nothing else is working. So remember CORS? It's back. So, wanted multi-region API gateway with CloudFront failover. Well, CloudFront origin groups don't support post methods. And we had post methods in our API gateway. Hence the problem. So, and not just post, but also put and delete API gateway actions are not usable in origin groups. So this breaks part of the API gateway functionality we needed. In my portal, user management, document operations, and the contact form all use post. So, CloudFront origin groups only allow read-only requests, no write or delete. So, couldn't use CloudFront for a true API failover. Can use it for the read-only, so all the retrieving of things can use fine. So, because of that, went back to a single region API gateway. While evaluating Route 53 DNS failover other options. It's a work in progress. Some other priorities have come up, so I haven't touched it in a while, but not the most fun. To some origin groups versus MREP trade-offs, there's automatic S3 failover for static websites. CloudFront origin groups have cross-region S3 bucket support, complex setup with bucket policies, replication, and health checks, but it's a cost-effective failover for static content that doesn't change frequently. When to update, when to stay stable. There's so many changes. It's hard to stay updated. Deciding what to adopt, what to ignore, and when to update is a challenge, especially as a solo developer. There's the decision fatigue from the churn. So, balancing innovation with stability and maintenance burden, as I found to be the best strategy for me, at least. So, as a brief summary, standard solutions don't always work. Be ready for custom approaches. You might need extra time for complex security implementations. Understand real costs versus benefits before committing to multi-region. Understand binary data handling things. Make sure you're aware of failover limitations. And focus more on stability than getting the latest features. So that's the lessons learned from what I've done. My contact information and survey if you feel like filling it out. Don't feel pressured. And thank you.